Aston Martin just locked their car in the garage, because Honda's engine may not survive a full race distance. Not a rumor. Not paddock gossip. Real thermal data. Real power cuts. Nearly 500 horsepower gone during deployment. 10 seconds per lap slower in certain runs. And the most alarming part? Honda did not have a corrected battery ready in Bahrain. This is not a small preseason glitch. This is a structural failure in the heart of the AMR26. While rivals completed full race simulations, Aston Martin was cutting holes into their own bodywork just to stop the power unit from overheating. And new vibration data now suggests the problem is not just electrical. It could be mechanical. Which means this partnership is under pressure before the first race even begins. If you think this is just testing drama, wait until you see what the numbers actually exposed. Subscribe now. Because what happened inside that garage could define Aston Martin's entire season. Let's break down exactly what happened that morning in Bahrain. Because this is where the tension truly started. Friday. Final phase of preseason testing. Other teams were running heavy fuel simulations. Long stints. Full deployment. Collecting race distance data. And Aston Martin's garage doors stayed closed. No installation laps. No system checks on track. Just engineers surrounding the car. Screens up. Silence. At first, it was described as a precautionary hybrid inspection. But internally, the situation was far more serious. Honda had detected abnormal battery temperature spikes at the end of the previous session. Not minor overheating. Exponential thermal escalation during aggressive charge and discharge cycles. And when you hear the term thermal runaway mentioned inside a Formula One garage, everyone understands the gravity. Because that is not just performance loss. That is safety risk. The high-voltage battery in the AMR26 is designed around a heavy electrical contribution. Close to half of the total power output. Which means if the energy store becomes unstable, the entire engine concept collapses. During long straights in Bahrain, the battery was delivering maximum deployment. Then harvesting aggressively under braking. And under sustained repetition, temperatures rose beyond predicted models. The safety system intervened. Power cut. Deployment limited. And here is the detail that raised eyebrows across the paddock. Honda did not have a revised specification battery available on site. No immediate replacement. No upgraded unit ready to swap in. They had to attempt a complex repair inside the garage, on a high-voltage system. That alone tells you this was not expected. Because preseason testing is when you expose weaknesses. But you also arrive prepared with contingency parts. The fact that spares were limited suggests the issue may have been underestimated. And then came the afternoon session. The car finally left the garage. But it was not the real AMR26. It was a restricted version. Hybrid deployment reduced. Energy release capped. Fernando Alonso completing short runs only. 3 laps. 4 laps. Back to the pits. Monitoring temperatures. Resetting systems. The car was nearly 10 seconds per lap slower in certain phases compared to the leaders. Not because the chassis is fundamentally that slow, but because electrical power was being held back to protect the battery. And this is where the tension inside Aston Martin truly escalated. Because the simulation data from Japan did not match what Bahrain revealed. Factory models predicted manageable thermal behavior. Real track conditions exposed instability. When correlation fails between simulator and reality, engineers lose confidence in their development projections. And that affects everything. Cooling design assumptions. Energy mapping. Long-run strategy models. But there is another layer. The AMR26 is aggressively packaged. Compact side pods. Minimal body volume. Designed to maximize aerodynamic efficiency. But tight packaging reduces cooling margin. There is less space for airflow. Less tolerance for unexpected heat. And mechanics were seen modifying the bodywork. Opening additional vents. Creating emergency cooling exits. Every modification increases drag. Every compromise reduces rear stability. So now Aston Martin is facing a brutal equation. Keep the aggressive aerodynamic concept and risk overheating. Or open the bodywork further and sacrifice performance. Neither option is ideal. And this is only block one of the problem. Because as the data continued to come in, another pattern began to emerge. One that suggests the issue might go deeper than just the battery. And that is where the real pressure on this partnership begins. Now here is where the situation becomes even more uncomfortable. Because once engineers stabilized the battery enough to send the car back out, new data began to surface. And it was not reassuring. Lance Stroll was the first to report something unusual under acceleration. Not just lack of power. Not just early clipping. Vibration. A deep mechanical vibration at lower revolutions. The kind that travels through the chassis, through the seat, through the steering column. And when drivers mention harmonic vibration, engineers immediately think about balance, crankshaft balance, motor generator alignment, gearbox coupling. Because modern power units are not just engines. They are tightly integrated mechanical and electrical systems. If one component is slightly misaligned, stress multiplies. Telemetry later confirmed abnormal oscillation patterns under partial throttle, especially during energy recovery transitions. And this is critical, because the AMR26 is not only struggling with thermal stability, it may also be dealing with mechanical stress inside the drivetrain. Now imagine this scenario. The battery overheats under aggressive cycles. The safety system cuts deployment early. Straight-line speed drops by more than 30 km per hour. Then, during lower speed exits, vibration loads increase on the engine mounts and gearbox casing. That is not one problem. That is a chain reaction. And chain reactions in Formula One are dangerous, because they do not isolate themselves. They compound. The more you limit deployment to protect the battery, the more you change load patterns in the internal combustion engine. The more you alter torque delivery, the more stress distribution shifts across mechanical components. Everything is connected. And this is where internal tension begins to grow. Because Aston Martin designed the AMR26 with extremely tight packaging, aggressive cooling assumptions, minimal airflow margins. That concept works only if the power unit behaves exactly as predicted. But if Honda's thermal and mechanical projections were slightly optimistic, the entire aerodynamic philosophy becomes compromised. Mechanics were forced to cut additional cooling exits into the bodywork. Visible changes. Unplanned modifications. Every extra opening increases drag, reduces rear downforce, alters balance. So now the team is no longer optimizing performance. They are managing risk. And that is a very different mindset heading into a season opener. Fernando Alonso's situation makes this even more serious. He has completed fewer laps than nearly anyone else. Less than 200 across both testing weeks. That means limited tire data, limited long-run modeling, limited understanding of degradation behavior. And preseason mileage is priceless. You cannot recover it once race one begins. Alonso admitted they started on the wrong foot, and far behind. That is not dramatic language. That is measured concern. Because drivers know when a project is delayed. They feel it in preparation gaps. And above all of this is Lawrence Stroll, an owner who invested heavily in infrastructure and talent, who positioned this Honda partnership as a long-term competitive leap. Instead, the first real test under desert heat has exposed instability, battery overheating, simulation mismatch, mechanical vibration, limited spare components, and no completed race distance simulation. This is why tension is rising. Because reliability is not something you patch overnight. Yes, software adjustments can reduce aggressive charge cycles. Yes, cooling tweaks can lower peak temperatures. But if the core architecture struggles under sustained load, development becomes reactive. And when a team enters race one reacting instead of attacking, the entire season tone shifts. The most brutal reality here is simple. Preseason testing is controlled, predictable, low pressure. If the AMR26 struggles under these conditions, what happens under race intensity? Wheel-to-wheel battles, dirty air, safety car restarts, full deployment demands lap after lap. That is the question now hanging over Aston Martin. Not whether they can fight for podiums, but whether they can finish consistently. And if Honda cannot align real-world data with their simulation models immediately, this partnership will begin under immense scrutiny. Because Bahrain has not just shown a slow car. It has exposed a fragile foundation. And in Formula One, foundations matter more than headlines. And here is where the situation shifts from technical concern to strategic crisis. Because once the engineers realized the battery overheating and vibration issues were connected to load transitions, a bigger question emerged. Did Aston Martin design the chassis around ideal Honda projections, instead of real-world tolerance? That is not a small detail. That is architectural philosophy. The AMR26 was built with extreme packaging efficiency, tight side pods, minimal cooling inlets, compact rear bodywork, everything optimized for aerodynamic performance. But extreme packaging leaves no margin for error, no thermal cushion, no flexibility if projections are slightly off. And Bahrain exposed that margin problem immediately. When the battery temperature rose faster than expected, the cooling system had nowhere to compensate. Airflow channels were already optimized to the millimeter, which meant the only solution was external modification. Cutting vents, opening panels, improvising airflow. and that destroys the purity of the original aerodynamic concept. Now imagine the internal conversation. Engineers from Honda reviewing their thermal models. Aston Martin aerodynamicists defending their packaging philosophy. Data analysts comparing simulation to reality. And leadership demanding answers before the first Grand Prix. Because once tension begins between a chassis department and an engine supplier, development slows. Not intentionally, but structurally. Every update must now be double-checked. Every simulation must be revalidated. Trust must be rebuilt. And in Formula One, time lost in alignment costs performance. But there is something even more concerning. The limited spare parts situation. Honda reportedly did not have enough corrected battery units available in Bahrain. That means supply chain readiness is under pressure. If another failure occurs during the opening race weekend, component availability becomes critical. And when teams start worrying about spare inventory before race 1, that is not a healthy sign. Meanwhile, competitors completed full race simulations, collected degradation data, optimized strategy mapping. Aston Martin did not complete a clean, uninterrupted race distance under full power. That is a preparation gap that cannot be ignored. Because race pace is built on long-run data, fuel loads, energy deployment cycles, brake temperature evolution, tire wear curves. Without that, race weekend becomes partial guesswork. And guesswork in a championship environment is dangerous. Fernando Alonso understands this deeply. He has seen projects collapse due to early reliability instability. He knows that once a team enters the season fixing fundamental issues, performance upgrades get delayed. Resources get redirected. Momentum slows. And momentum in modern Formula One is everything. So what does this new evidence truly expose? It exposes a mismatch between ambition and synchronization. Honda's power unit may have strong theoretical performance. The AMR26 chassis may have aerodynamic potential. But right now, the integration between both is incomplete. Thermal management unstable. Mechanical balance under question. Cooling margin insufficient. And internal pressure rising. The most critical test now is not raw speed. It is correlation recovery. Honda must recalibrate simulation models immediately. Aston Martin must evaluate whether packaging adjustments are temporary or structural. Because if these two departments do not align quickly, development direction becomes fragmented. And when direction fragments, seasons unravel quietly. This is why tension inside the team feels heavier than usual. Not because they are slow, but because the foundation appears uncertain. And if race 1 confirms the weaknesses Bahrain has already revealed, the narrative around this partnership will change dramatically. From ambitious long-term project to urgent damage control. The real question now is simple. Can Honda and Aston Martin stabilize the AMR26 before competitive pressure magnifies every flaw? Because if they cannot, the season may begin not with progress, but with survival.